Hello, sir. Myself Sheikh Kadir, sir, East Godavari technical head, sir. I'll take 1 minute time to tell you that RMC plant in Kakinada very soon, within 10 to 15 days, sir. We are going to start all our services. Comparing to other plants, we have whatever the different types of special concretes which are explained by our Raman sir, all are available here, and the price will be very competitive with whatever already you are using. He is Chaitanya, our sales manager sir, will give the price inputs and will close this.
గుడ్ ఈవినింగ్ సార్. నెక్స్ట్ మంత్ కానీ ఈ మంత్ ఎండింగ్లో కానీ మనం ఆర్ఎంసీ ప్లాన్ స్టార్ట్ చేస్తున్నామండి. ఇక్కడ ప్రైస్ ఆల్రెడీ మనం లోకల్ వెండర్స్ దగ్గర నుంచి మనం తీసుకుంటున్నాం. రా మెటీరియల్ ప్రైస్ అది వెరీ సూన్ మేము కొటేషన్స్ కూడా సబ్మిట్ చేయడానికి రెడీగా ఉన్నామండి. మనకి ఏదైతే కొత్త ప్రాజెక్ట్స్ స్టార్ట్ అయినాయి, లేదంటే ఎగ్జిస్టింగ్ ప్రాజెక్ట్స్ కానీ సైట్స్ కానీ రిటైల్ కస్టమర్స్ కానీ ఎవరికైనా కానీ మనం వాల్యూ యాడెడ్ కాంక్రీట్స్, రెగ్యులర్ కాంక్రీట్ ఏది వాళ్ళకి బెటర్ ఆపర్చునిటీ బెటర్ అక్కడ అవైలబుల్ ఉంటుందో అది మనం సప్లై చేయడానికి రెడీగా ఉన్నామండి. వెరీ నియర్ ఆల్మోస్ట్ ఒక 10 daysలో మనం స్టార్ట్ చేస్తాం.
You please give me the quality assurance plans also. Besides the pricing, it's better to have the quality assurance plans also.
Yes,
ఓకే సార్. లొకేషన్ నియర్ ఇస్కాన్ దగ్గరలో వస్తుంది. ఇస్కాన్ దగ్గరలో వస్తుంది. మనకు ఆల్రెడీ ఎగ్జిస్టింగ్ రాజమండ్రి ప్లాంట్ ఉంది, నెక్స్ట్ వైజాగ్ ఉన్నాయండి. అంటే మన కస్టమర్లు ఇక్కడ ఎవరైతే మేజర్ ప్రాజెక్ట్స్ చేస్తున్నారో వాళ్ళందరికీ కూడా మనకి ఆర్ఎంసీ గురించి ఆల్రెడీ వాడున్నారు. ఇక్కడ కాకినాడలో కూడా వాళ్ళు కూడా వెయిట్ చేస్తున్నారు. మీ అందరు సపోర్ట్ ఉంటే మేము
The awaited lecture of Sri Surya Prakash Garu. I now request Sri L.S. Subramanian Garu to introduce Surya Prakash Garu.
I have to go there.
Good evening to you all. In fact, Bajwa Prasad gave me a text, then a brief CV of Sri Surya Prakash. But I will try to, there are so many jargon, technical jargon, which I may not be pronouncing correctly, but I will try to take it. Raju. Is a consultant and a mentor who has made a significant contribution to civil engineering. Mr. Surya Prakash obtained bachelor's degree in civil engineering from JNT in 1986 and did MS in structures in 1990 from IIT Madras. After working for 6 years as a design engineer, he established the Sachwani projects and consultants in 1994. Here I would like to say something. I worked for you a very brief period in Shahjahan Towers and Khairabad. Still your office is there, I think, right? And he is also, actually, that time I was in R&D department, still I worked for him. He is also the founder and mentor of Smart Infra EST, a trust dedicated to civil engineering to enhance the employability and employment. Morning we had a very nice lecture about this. He was a president of ACCI 2013-15 period and is a founding president of PSI since 2013. Engineer Surya Prakash's professional memberships are FIE, FSCCE India, MSCI, MIRC, MANSDAG, M3IIB, etc. and is a council member of the IEI in Civil Engineering Division 2125. Not only consultancy, he authored a book on design and implementation of communication of towers. Morning we learned that he was instrumental in designing more than 3 lakh towers in India. Give him a big hand. So yes, Surya Prakash is a training faculty at CRE, ESIC, ESCI, Hyderabad, and CAD of transmission tower lines. He is a chief resource person for LEAP, lectures in 56 topics for Smart Infra EST. I give you additional information. He has got his YouTube channel. His lectures are more than 200 to 300 lectures are on YouTube. Just try Surya Prakash. Morning I tried, so I got it. So you can also try, but they are a bit lengthy. Have some patience to listen. That's all. But a good dissemination of knowledge. Even I had a pleasure of listening to the Vedic Bhavan, which you designed, Veda Patsala on the edges of Kanchi Kamakoti and Sringeri thing. That was the one I had seen in the morning. So the CAB FADD software developed by him won the ACCE CDC Best Software Award in 2007. He was the organizing secretary in 2004. He organized workshops on TEPSCon 2014-15 and EIA 2003. It's like a very epic jargon for us. And IS 456. New vistas, seismic design of buildings, IS 990, 1996, IS 1999. He is a member of the expert committee for calculation of seismic damage structures. He was appointed expert committee member by AP government for review of projects in irrigation, affordable housing and capital Amaravati works, totally costing about 1 lakh crores. Engineer Surya Prakash participated in several international conferences. In 2002, Singapore, SCWC, COMA, Italy 2011, Seoul, South Korea, IASS 2012, Precast 2014, Moscow, SCWC 2015, Singapore, SCWC 2018, Istanbul, FIB Congress 2022 at Oslo. Morning he was referring to his conference at Oslo. He guided projects for MTech and BTech students of engineering colleges, IIT Madras, JNTU Hyderabad, NIT Warangal. He is also involved in the training of engineers. It's a very good thing. You go through the YouTube thing, you will know what kind of training he imparts to the budding engineers in Ceylon. It's pleasure to have listen to the YouTube. Engineer Surya Prakash handled several prestigious projects during the past 3.5 decades of his illustrious career. Some of the projects he undertook include affordable housing, buildings, residential, commercial, office, IT, industrial, hospitals. It is like the number of degrees held by Sundar Rao Garu. You know, it runs into number of lines. Go on reading it. So I have many, like hospitals, hostels, infrastructure, roads, bridges, metro, and whatnot. You name anything, that is here in this. Yeah. Even that is also not sufficient. Transmission line towers, FM, TV, microwave, cellular towers, providing architecture, engineering, project management services. Prestigious clients include Ministry of Finance, ILFS, Tech Mahindra, GVK, GMR, BSNL, Idea, Airtel, Tata, Saket, Manjeera, Janapriya, only to name a very few of these things. Now I present Sri Surya Prakash to you with his, I think he will enthrall us with his scintillating lecture in another half an hour or so. Thank you so much.
Now I request Engineer Surya Prakash Garu to deliver his technical lecture on buildings in distress and SOP for healthy and durable buildings.
Today I am very happy being introduced by none other than a senior person in our engineering sector. Actually, I have come prepared for 1 hour lecture, but I'll reduce it to half an hour. No, overall time itself. we started late by 45 minutes. So we have to manage, being engineers, we have to manage the time. And you are all aware, recently we have seen in our ACC groups that in Chennai, there was a building, 17-story building, which was occupied about 5 years back, and it started falling due to corrosion. In fact, that prompted our Secretary Durga Prasad to ask him to present what are the such distresses in the building that we come across and what is the solution. The solution I offered was about 3 years back to CREDAI Hyderabad. I authored a book on SOP, actually it's not included in my introduction because it's a recent one. And our company authored the book on SOP, Standard Operating Process for design and maintenance of the buildings. It was starting from planning to design and implementation and then maintenance, handing over also. So today I'll be sharing quickly, I'll not go into any detail. I have 320 slides actually, but I am expert in running the slides fast because I've been giving. So these are all the 3 projects that we have done. ISB 20-story building, GVK Mall, and this is APIS in India, office building. These are the 3 buildings. Oh, okay. So my overview is introduction, building distress, and case studies. I will share some of the important case studies that I have come across. And the consultants, role of consultants and misnomer in because we are all consultants. First of all, I don't like the word structural designer. We are not just structural designers. We are civil and structural consultants. In fact, without civil, there is no structure. So first we have to correct that to our client. And the building construction SOP and causes and remedies, final. This is my overall overview of my presentation. And the forensic, what I am going to present is a forensic audit of the distressed buildings. That means technically what went wrong and how it went wrong and how to correct it. And then who is responsible for it and how to educate the clients on that, and then need for SOP. This is my topic today. And inception stage, the most important thing I always tell my clients is they have to spend time with the consultant. Unless we understand their requirement, what they are planning, functional requirement. All consultants should spend more time with the clients to understand the functional requirements and draft a document, FRD we call, functional requirement document, and the client interaction, and then prepare the design intent. That client won't understand. This is for us, our consultant. So then design basis report, after design intent, we prepare which codes we follow, which loads we have to incorporate in the design. And then investigation, most important. That is the soil investigation, geology for large projects like power plants and high-rise building, topography, environment, materials, availability of materials, which is very important. And people like Venkatraman will solve it quickly. And skilled workers and machinery available, and resources like farm work and all the resources, material handling. These are all the resources that we require. And then go for the concept design based on this investigation and inputs. And design coordination. This is the most important. Today only I had some SOS in our lunchtime from site. Some coordination issues. Of course, it's a complicated project, but there will be coordination issues if we don't have coordination prior to the design. Coordination with electrical, coordination with air conditioning, coordination with plumbing and sanitary, firefighting, interiors, all we have to incorporate into our design. So this is the formulation stage where we start with the statutory appraisals, design development, and then construction engineering. This is what is missing in most of our consultants. In fact, unless we think of construction methodology, what construction technology we are going to adopt in the construction, that comes from availability of time, cost, and availability of the technology itself. Planning, quantity survey, and buildability. Buildability is ignored in our country. When we start the construction, then we realize it is very difficult to transport the material or lift that particular material. So these are all the things which we have to consider before only. And then we prepare the detailed project report and then go for the technical sanction and just refreshing the process of the design. So that when I further talk, these are all the terminology I am going to use. Bid documents, tender documents, quantity, specification, schedule of items, quality and safety. These are all the sections in our bid document which will take care of. So next comes the construction stage. Once we have done the formulation and then in inception, formulation and then construction. So in construction we have site enabling, most important, with the power, water, security, access roads, stores, office, labor, accommodation, internet, CCTV, boundary wall. These are all the aspects we covered in SOP actually. How to do this for a project. What is the size of the project? What are the requirements of power? Recently I got a call from my client. What is the generator I have to install? There is a power cut suddenly. So we have to tell quickly what is the generator required. But in planning itself, we have to do it in the beginning. Material test, concrete mix design, block marking, soil test, QC lab, sample room. Large, it's fairly large. Above 5 lakh square feet, we have to have a sample room at the site. Even up to above 2 lakhs also. Quality registers, which I have shared in the SOP. Actually, it is available in my website also, in my YouTube also. We have adopted all the 22 quality registers as per the CVC norms. It helps engineers, not the clients, following the quality registers as per CVC norm. Then method statement. This is what I am incorporating now in every project. We know that in most of the sites, when an engineer goes for inspection, he will start finding faults in the site. What we are doing actually, we are only giving a drawing to the site. Are we telling how to do the flooring or how to do the waterproofing, how to do the plaster? Unfortunately, the skill levels are dropping, and unless we give a method statement for plastering, masonry, that's not going to happen as per the quality we expect. And there is no point in finding fault after going to the site. So better prepare the method statement. We are standardizing these method statements for standard activities, and we have to issue that along with the drawing. So that if he follows the method statement, what are the safety aspects, what are the scaffolding to be done, what are the resources required, then only the work will happen as we think, as we have envisaged in our drawing. Stage passing, that is prior to commencement of activity and after the activity. We have to pass the stage, acceptance of the work done. Suppose we have done the excavation, we have to start PCC. So what are the tests to be done before PCC? About the level of the pit or soil capacity expected, which simply write in the drawing. You go to the depth until you receive the hard strata. This is a standard note we give in the drawing. But what is that hard strata? It is actually SBC required. And Umesh Rao, I don't know whether he told you or not when he came here, we have a crowbar test for SBC. So crowbar test is nothing but depth in inches, 50 by depth, that is the SBC. So like that we have empirical methods to identify the hard strata. Then milestones in the project, the slabs, mainly any project we plan, ultimately the cycle time of the slab is the determining the overall project completion time. Next is the desnagging. After we do the work, before handing over, desnagging. This is what we miss in our schedules actually. There will be snags in construction. Any at site, you have a lot of problems happening, and unless we keep the time for snagging and desnagging, we will not complete the project. Otherwise, after occupancy, we will be doing this desnagging. Handing over. These are the steps in construction. Now consultants. We are all consultants, and what is our scope? That's what I said. We are not structural designers, we are civil and structural consultant. Let us correct ourselves. And the civil is a missing scope always. There is a structural consultant, there is an architect, there is electrical. Who is civil consultant? So we structural engineer have to do the civil also. And construction engineering. If we are doing only structural design, Who is the structural consultant then? Structural consultant is the one who takes care of construction engineering, every aspect of construction, planning, functional requirements. Next is the construction engineering, is a missing scope. In our office, we have a construction engineering department which will bridge the gap between design and construction. So construction engineering has to translate the design into implementable construction. Then construction supervision by qualified engineers, civil and structural consultants to insist on certification by qualified civil structural chief engineers. So next is geotechnical consultant. We call soil consultant. I don't know that name where it comes from. Geotechnical consultant is the one not just for giving SPC. I've seen soil reports, 1-page paragraph. The SPC recommended is 30 tons per square meter, certified sign. How can I accept that?
That is because of the client. They are not expecting more than that.
So we have to educate the client. That's what I said in the video.
Though we explain all the things, they are not accepting. They have to pay the amount for only for that.
I never accept, in fact, there are projects, sir, where I have done soil investigation or geotechnical investigation 4 times. Unless I get boreholes and complete data which is complied, I will not accept the report.
It is correct, sir, but
We-
the society, that's what I'm saying.
Next is the cost consultant, quality and safety consultant and cost consultant, proof consultant. This is also very important, the peer reviewer of the design. And then planning engineers. This is another missing scope in many projects. We don't have planning engineers. What is the role of, you can see in my YouTube, we have defined scope for planning engineers. There are 15 lectures on planning engineering. Starting from QS, studying the drawings, to planning, construction itself, scheduling. People think that we have to understand the method of construction and time required for each activity. Now failure. This is what is my main scope today. What is a failure? Why failures happen? Failures happen because of the mismatch between design and construction in actual condition. Loading, accident, material, construction method, structural system, corrosion, and expected life. These are all the aspects that I will be sharing today. And general loads like seismic, wind, dead load, and live load, and soil, settlement, liquefaction, expansive soils, and caving. These are all the, I will be sharing the case studies of this quickly. I will not spend much time. And accident means fire, blast, impact, flood. And materials are poor quality, wrong specification, or shelf life, which we are talking about. The concrete or cement or chemicals, maybe, what we use. Then structural system engineering error. I'll share examples where it can go wrong. Corrosion and life of structure and quality plan, quality assurance, quality control, audit, materials, works and workmanship and tolerances. IS 1200 is most important code many of the civil engineers don't refer to. It's very, very important. Clients say your quality is not good. Even if it is in tolerance, you have to tell what are the tolerances and where we stand with respect to the tolerance. Now I'll get into the quick case studies. Interesting actually. Some of them in my project, some of them I have taken from others. Excavation, shrinkage, formwork, staging, wind and masonry. Wind, masonry failure due to wind. Have you come across anywhere? Nowadays we are talking about lightweight bricks. There is no code actually for stability. Whatever code we have, I'll share that details. That only talks about clay bricks.
Sir,
Unit weight.
in JN2 Hyderabad, I think one facade failure is there due to the wind. The JN2
Maybe I'll share my case.
university case.
What I have come across. And then pore water pressure, corrosion and clay soil. So these are all the case studies I'm sharing today about, in 2 stages I'll share. Deep excavation shoring is very, very important. I have done at least 2-3 projects of deep excavation more than 20 meters within the city where we have buildings next to that. And my problem is, as a consultant, I have studied the soil report and I have recommended one method of shoring. Contractor takes deviation. Because you know, contractors go by their available resources. So there is a mismatch. I qualified my statement, but accident happened and people died. That's the unfortunate thing. But this is where we have to be careful. If I had not qualified my design basis report about the quality shoring system, I would have been behind bars as an engineer, because I am responsible for the safety of the people. So I'll show with the pictures. This is the building and excavation next, and this is the shoring that is done. Touch piles we call it. And you know that is a 20-meter deep piles.
Second pile, sir?
Yeah, second pile. So this is the shoring. This kind of shoring you can adopt in uniform soils actually, like normal soils, either clay soils or sandy soils or normal soils, mix of clay and sand. So we had two pockets of excavation. In one pocket we had uniform soil where we accepted the shoring touch pile, and other where we had varying strata. We have the soil, we have the soft disintegrated rock, and then hard rock. So what happens is before you excavate, you do the shoring. Piles you drive. When you drive the piles, you come across the soft disintegrated rock. You think it is a hard rock. It's very difficult to distinguish before opening the excavation. So before opening, we have done the shoring already. So they have terminated the piles at that 12 meters depth. And you can see the soft disintegrated rock. And they have done using the breakers, because we are not allowed casting. When the breakers were done, there was an undercut below the piles. And you know, these piles are put by anchors. So these anchors depend on the wedge. So they assume that piles are standing vertically stable. But once there is undercut, the pile settles. And the pile settles, wedge releases. When the wedge releases, there is no angle. All the piles will collapse. So this is what happened exactly. So fortunately, we did the structural health monitoring of the adjoining buildings. We installed the sensors. We have recorded. We could exactly find when this fell because of this. So when we have accepted with our qualification, we knew the risk and we have monitored the risk. So we could reduce the damage, and that whole thing collapsed. Before picture we had piles, now there are no piles. It has collapsed and we restored in 48 hours this stability of the building, because the people are concerned about the building where 2,000 people are working, IT people. Next is the excavation collapse. This is mostly happens in the site. Normal foundation excavation we do, and the normal tendency of the contractor is to dump the earth on the excavated side. Already there is a shear imbalance, and we are adding the overburden, and it fails. So in one of my projects, 5 people died, and next after that, I have put my big bold note that don't dump the earth on the side of the excavated side. Next is the piling test. This is another major thing happens in most of the projects. The method of boring determines the capacity of the pile. We design theoretically pile capacity as 200 tons, 250 tons. But actually when we do the pile test, initial pile load test, we are getting 100 tons capacity. Though theoretically it is 200 tons. And it is because of the boring method. Next is the double staging collapse. In most of the construction sites, whenever we go for double staging, if it is not designed properly, there will be collapses. We have so many failures of slabs during casting in Hyderabad, in many cities. So people die also, and in many projects it happened. So we have to be very cautious when we are giving the double staging. We have many systems available. We have to insist on those systems to be used. Canopy. This is another very, very important, because canopy, you know, it is independent. In normal building, we have all 4 sides columns, whereas canopy, we don't have any columns on one side, free cantilever. So there can be collapse towards that. So we have to brace it and anchor it to the main columns in the building. Next is the slab design failure due to torsion and corner span. This most occurring error in flat slabs. In flat slabs, we use the direct design method, and direct design method has got so many qualifiers, like minimum more than 3 spans, and span to span variation should not be more than 20%. All these qualifiers are there in the code, but in the many projects we ignore or we miss. So that we have to be very careful, and so this is the result of that. In a flat slab, we have to do the strengthening by introducing the steel capitals to the columns. Next is the flat slab design failure due to this is what I said, inappropriate use of direct design method, number of spans and span difference. Next is the no final setting due to excessive retarder. This happened in the initial stage of ready mix actually. You know, they give the retarder to the driver, truck driver, transit mixer driver. And that fellow, to save his time, whatever is given, he will pour and start the truck. And we casted the slab. After 24 hours also, there is no initial setting
The
in the slab.
superplasticizer has also similar effects, sir.
No.
What this is?
What does it?
What is the
Anything, we have to
superplasticizer?
follow the next design. I'm talking about the retarder here. Retarder we use for delayed initial setting.
Yes.
Maximum 4 hours is what we allow. To our design also, people have poured the excess retarder and this happened. Next is the shrinkage cracks due to dry summer and improper curing. Fortunately, maybe in places like Kakinada it may not happen, but Hyderabad we face this very often in summer particularly due to the humidity is very low. That's a dry climate and there will be plastic shrinkage very quickly. And most misleading is the cracks that appear actually, because shrinkage also happens like we have a solution for that. It follows the failure recipe of 6 stages of level record, particularly in potential slabs. You have to record the levels of the shuttering before concreting, and you have to record the levels of the concrete after concreting, and you have to record below build. So we have to do the after construction. EPS and client wants to add 2 slabs overnight, and we have to take care of that. Next is the pour water pressure to closure of relief valve. In fact, in 30-story building, we have done a raft with the 2 basements, and then we have estimated pour water pressure, and we have given a relief valve for pour water pressure relief. You know.
Uplift relief.
For uplift and below, yeah. Subsoil drainage. Subsoil drainage. And it so happened, client to, after 10 years of the construction, they thought, why this open well, we'll close it, but they have plugged it.
Sir, is there any instrumentation that was done?
No,
For the measurement of
unfortunately, this is about 15 years back, we didn't do.
But we have the instrumentation, sir.
Yeah, I know.
Right.
Now we have very good advanced instrumentation, stress monitoring and all. So this is the podium structure. There are 2 towers of 30 floors, and in between there is a podium. On the podium we have a swimming pool and a clubhouse and all beautifully done. And overnight it got lifted. Podium got lifted, 2-story, and columns cracked like that. Shear failure
Shape.
in the columns. And this is the structure, podium structure, and this is the swimming pool and all. This is the model we did after that to estimate the pour water pressure and then why it has the deflected shape. We restricted the design to 2-meter pour water pressure, whereas the pour water pressure increased to 10 meters. Because of plugging, given the relief to the pour water pressure, the podium has come back. That is the beauty of engineering. And this is the profile of the water table. We have plotted the profile of the water table and then designed that. This is the water flowing after giving the relief to the pour water. We ignored the well and then we have created a water system to release the pour water pressure. Next is due to closing down of spouts. This is a very classic example. You will come across definitely. We designed the terrace, large span structures, and during construction for curing we plug the spouts, downwater spouts, you know. Then we forget that. Then there is a heavy rain one day, and there is a 1 meter water nicely stagnated on the terrace, which we don't design. No terrace we design for 1 ton load, and the slab failed due to that. Next is due to flooring, due to expansive soils. This is the clay soils. This is another very classic case where about 1,000 buildings were failing one by one. Every year, 5 buildings are failing. And then we had to give a solution, external solution, because you cannot solve 1,000 buildings. What we did is we studied the water table and we released the water table so that there is no expansion in the clay. Instead of solving, attacking the expansion, we attacked not to have expansion.
Reverse engineering.
Yeah, reverse. So these are all the cracks that happened in those buildings. Expansive. See the gap in the brick wall. And these are all the very important buildings actually. These are and next is the masonry wall collapse due to wind. And they have used the lightweight blocks, AAC blocks. Particularly when we use the AAC blocks in the buildings, we have to check the stability due to wind. And we have done about 20 years back also the method of bands, creation of reinforced bands and mullions. And if you calculate, for AAC blocks, many people complain about cracks in the walls. One is due to the bonding and the other is due to the design itself, structural design itself. So for structural design, our recommendation is don't exceed 6 times the thickness of the wall. The height, normally we follow 18 times for the wall. If it is, you know what is 18? 18 is unit weight of brick wall, kilonewton per cubic meter. Whereas we are using AAC blocks which are per cubic meter. So you have to follow 6D for the height of the wall and create the band. So this is the total wall collapse. Of course, it's an exceptional case. It's a steel structure actually. And in a steel structure, they have used lightweight blocks. So these are all the lightweight blocks collected after collapse. So we have verified this design and the solution. And also this large windows, very beautiful, not structurally designed. Windows. We have to, what I'm trying to say is, we have to design brick walls, we have to design doors also. So this is very, very important. Let's not take anything for granted. There is no structure that can stand without design. So this is the analysis that we did and found that the deflections are very excessive and we could justify the collapse and then we have given the reinforcement to the structure and then retrofitted that. Next is the corrosion.
Sir, one question.
Yeah.
Regarding this CLC.
There are no bands, there are no mullions. Actually, wall cannot transfer the load, you know. You have to, either by stability, normal overturning moment we have to check. If it cannot resist the overturning moment, provide the bands and create a frame within the brick wall itself and create small panels of the brick wall which will transfer the load to the mullions and bands. That's what we have been doing.
So like whatever you told, 18 times or 6 times, is there anything million to million
Length.
calculation?
Actual length of the wall in AAC blocks, you should not exceed 10 feet. Yeah.
So that how do
You create a mullion, anchor it to the top slab and the bottom beam.
the reinforcement in just
Yeah, reinforcement, and you can design that.
like a structure?
Yeah, exactly.
construction guidelines of the AC blocks.
Yes, yes,
Yeah.
we have the IS codes, sir.
Yeah.
Yeah,
Now
the
we
IS
have
codes
the
for
IS
that.
code. I have developed this methodology. Yeah.
Yeah, yes. 3, 4.
We have been following. In my projects, we never got any problem where we have designed, because we have been designing. But after
1905 is
seeing
for.
this kind of cases, I thought I must include in SOP this method. Next is the corrosion. So this is a industrial structure, steel structure with excessive corrosion in the steel because the exposure condition and the protective coating that is required for the steel was not given. And next I'll show you the case of concrete. So see the condition of the structure. So this is the kind of fumes. And next, this is a building in Calcutta. And this is the concrete. You can see the reinforcement. You don't have to use a rebar locator. It shows by itself. So this is the steel in columns as well as beams and slab. Entire steel corroded because of inadequate cover. Because of exposure condition being not taken as CD. So So we have IS quadral provisions, but they are not followed in this. See the column. And this is columns, ties also you can see. Next is part 2, structural system earthquake. I'll quickly run through, I'll not, because time is running short. So structural system is very, very important. Projects, this happening. People take STAD results and provide the steel. Who will do the detailing? Have you plotted force diagram for your structure? This is what youngsters, I'm not saying, we all seniors, we have learned bending moment diagram and shear force diagram. But unfortunately, once the STAD result comes, they would have struggled with STAD to get the result. Once the result comes, they will give it to the draftsman for steel. Like SBC in soil, steel, tension steel and compression steel, that's all. We are not detailed. So you can see there was one building, in fact referred to me, it was leaking. They thought it's only waterproofing problem. When I went and saw, I found much bigger than waterproofing. In fact, recently I shared about waterproofing advertisement in our ASC group, I think. I objected to waterproofing people advertising, just use this membrane, it will solve your deep seepage and leakage and forever. That's not correct. First the structure has to be, base to be proper. Here, that's what happened. So here, these are all the photographs of the building. What happened is, you know, when you have the grid of beams, there are primary beams, there are secondary beams, there are tertiary beams, and there are cross beams. So in this, what we found is, we got the drawings of the structure. It was done by proper structural engineer only, but detailing was not done according to behavior. So primary beam is treated as tertiary beam, secondary beam is treated as primary beam, like that. So it has failed, it deflected and cracked, and we found a lot of cracks. You can see this crack. Another interesting, in my project only it happened, my office has given a drawing saying typical detail of the beam. Support, they have shown as columns, and then provide longitudinal steel curtailment. Inside, they don't know, no? The site engineer, they thought that support is beam to beam. And they have curtailed the whole main reinforcement. And it cracked. When I went to the site, I just quickly, within 10 minutes, we could locate the error and we have given the solution to that. So this kind of things will happen. That's why I'm sharing this. We cannot give it to our junior engineers or detailers for drawing, and we have to verify, being the main structural consultant. So we did that solution, and also the cracks in the walls. We have done the stitching and given solution so that there are no further cracks after that. Because basically the structure has failed. So we have to restore the structure and we have to restore the masonry also, structural. So this is what we did. And next is the earthquake. As introduced, I was in Ahmedabad on 30th of January 2001 after the earthquake. I spent 1 week studying the failures, and none of the buildings are designed for earthquake, unfortunately, though it was in zone 3. So we found a lot of problems, so see the call. So many, and lift core, you know, this is the core actually, and it's a phenomenon, reversal, stress reversal phenomenon in the brick masonry.
Yeah, diagonal tension
Yeah,
crack in
diagonal-
both sides due to the reversal of earthquake.
Yes. So these are all the things which we have given a restoration method. And main, we have now IS 1893, the stiffness variation between the floors, and open steels particularly, there are problems like this, and so we have given the standard stiffness method, like for a common man, so that you give the brick walls, whatever total brick walls you have in the upper floor, you give equivalent thickness in the silt so that it will contribute to the stiffness and reduce the difference between the stiffness. That's what we have given.
To eliminate the soft story effects.
Yeah, soft story. So we have done that restoration, and then, next. So earthquake, we have given a report, and there should be a structural engineer, there should be a geotechnical engineer, there should be a supervising engineer. Unless all three sign, you should not accept any building as structurally stable. Next is the fire. fire accidents do happen. Till this fire accident happened, I used to think that post-tension slabs are not good against resisting. But this accident has given me a lesson that, see, this is after the fire. Whole reinforcement, bottom reinforcement got exposed. Whole cover spoiled, and this building was safe actually after the fire because of post-tension. And we restored this, of course. See the drop panels. It was a flat slab. And drop panels also reinforcement got exposed. And we restored this after investigating. Here that levels helped us. We did the level record. That level record helped us, and we could restore that. Next is the fire accident in steel structures. This is another fire accident. See how the strong I-beams, we think, how they get twisted in the fire due to the temperature and without treatment for the fire. So this is another inverted beam neutral axis. This is very, very common thing. It happened about 30 years back also. It happened recently also. Mostly we detail the inverted beams in the slabs, in canopies also. We fail to check the neutral axis, depth of neutral axis, and then we don't provide the top reinforcement in the slab. In inverted beam, the whole slab will be in tension, and the slab reinforcement in the top layer, it is going to crack. So that kind of through crack in the slab, from the top it initiates and it extends up to the bottom. So we have to check this. Lack of weatherproofing, this is another. I'm sure you must have come across in even 5-story building, every 5th floor will be having extensive cracks. This is very, very common. I am giving solution for that. To avoid that, one is weatherproofing, that is temperature control. You give the insulation. Brickbat also is good enough. Not screed actually. Concrete screed is not weatherproofing. Concrete screed can give you slope only. Weatherproofing is very, very essential. And then you also provide in every terrace that is for temperature only. And you have to provide proper temperature analysis. For the top floor is free to expand. That's why in top floor you get the cracks. So you can solve that. And next is removing counter props. This is another interesting story in post-tension slabs. We have post strips in post-tension slabs. When long building, not small building. If the building length is more than 60 meters, we'll have post strip. You can have up to 60 meters. Beyond 60 meters, you have to give a post strip and then do it. Knowing this, in our drawings, we have mentioned that you have to keep the counter prop for 3 slabs. And you cannot keep 4 strips unclosed for more than, this is the note we have given. But what happened? They have left the 4 strips in 2 slabs. Counter props also they kept 3 levels. But what happened? Midnight, 2 o'clock when concreting happened, they needed some props, and they removed the counter props. It affected 3 levels of slabs failure like this. See this. This is the cracks in the slab of 13 meter span. Imagine. And this is the post strip, and this slab has become a cantilever slab because they removed the props. And we have jacked up and we rehabilitated that. And next is micro segregation. This is very, very interesting case. In fact, it was a precast construction. Wall panels are being cast at the site. When I went to the site, I asked my engineer, what is this? You are finding reinforcement pattern in the dampness. It is common, sir, it is that. No, it's not common for me. So I went into the detail. I went to the site of casting this wall. Then I checked the water cement ratio in the mixed design. It was proper, and they are casting properly, but I could see water flowing. That means there is excess water. How it is happening? Batching plant, it's not happening. At site, it's not happening. Then who is the culprit? Transit fixer, the driver. And Mason asked the driver to add water to keep it running. And for Mason, it is easy. So this is what happened. Found the reason for micro segregation. Shoring pile, of course, I have explained. This is the case in Vijayawada actually. Clay soils. Shoring piles in clay soils. Here, the anchorage was not done, what I have shown. And we have done the analysis, I'll show you interesting. This is the analysis. See the capping beam has reflected out because it's not anchored. It's very difficult to anchor in clay soils. You cannot give the soil anchors in the clay soil. And next is the pile load test failure, of course, I explained. Next is the blast, of course. Blast also can happen, so we have to take care. This is a small residential building where LPG cylinder blast happened. Whole family died actually. But building also collapsed. Now the causes and remedies. Plinth beam. This is a very, very interesting thing. Many people think that if you provide a plinth beam, there is no CRS wall required below. We have to consider the natural ground level and formed ground level and plinth level and provide the proper retaining and confinement for the wall, soil. Curing. This is another important thing. For columns nowadays, nobody is doing this gunny bag or continuous curing. And wall plastering. This is the actual photograph when I went to the site. See, there are no strips of the wall. In the olden days, we used to provide the level of the plastering and then create the strips and maintain the plane. Nowadays, and we are complaining of cracks in the plastering. And simple air crack is a common word. And we accept air crack, it's okay. But why it is happening is because of the, I'll ask another important question. When we have a two-coat plaster, external wall, in two-coat plaster, what should be the richer mix, first coat or second coat?
First coat should be the richer mix. Oh, that should be 14 mm.
In most,
12
I ask this question to most of the engineers, they give a reverse answer. Because they find the finishing, for mason, second coat richer mix is better. Should be the leaner mix, but use the, that should, because of this not being followed, you get cracks in plaster. Sure, because it's shrinkage.
No, only if the mason prefers to provide two coats, Dubara.
Yeah.
Dubara is only single.
Yeah.
Here we do only one line, that's all. Nothing more than that.
Okay.
So cracks are imminent.
Next is the waterproofing. Giving specification for waterproofing below the footings. If you are not below the footing, the exposure condition is not normal. It is severe because always when you excavate for footing, there will be water collected in the pit. You are disturbing the natural soil strata. So when it is exposed to water for continuous 2 months, 3 months, the footing, I have got the photographs of the footings removed after 10 years. And I have taken the pictures of condition of steel below the footing. They are not proper. They corrode actually. They are in tension. So what I say is, either we are giving 50 mm cover for the footings bottom, but are we checking for the stress? For
Crack width, we have to check it as well.
check it. You have to limit the crack width to 0.00. The strain in the footings you should not permit. Otherwise, provide the waterproofing.
One more thing is the side cover is also much more important for the footings. It's 75 mm. Bottom cover
But
is
here you
150
see
mm.
what we are giving is an annular, water annular for the entire structure and the retaining walls and the slabs and these water retaining structures, some for swimming pool and all these, manholes and then terrace, all this. So this is the landscape on podium terrace. We have podiums in the building and how to do the landscape. Architects want landscape, but we have to give this required. This is the drainage, drain cells actually. We have done